All right, let's talk about a pattern that is, and I'm not kidding, a programmer's superpower. It's called the frequency map. You're going to see this thing everywhere, from job interviews to the apps you use every day. By the time we're done here, you'll get it, and you'll know exactly when to pull it out of your back pocket. So let's just jump right in.
Okay, let's start with a really simple question. Imagine you've got a list of stuff. It could be numbers, words, you name it. How would you go about finding the one thing in that list that shows up the most? Now, it sounds pretty simple, right? But how you answer that question, well, it says a lot about how you think like a programmer.
And this happens to be a classic coding puzzle, finding the most frequent element. Let's take a look at a real example. So, let's get concrete. Here's the challenge. You get a list of numbers, something like this one. You can see we've got a bunch of 1s, a couple of 2s, and a 3. The mission is to figure out which number appears the most. And yeah, you can probably just look at this and see it's the number 1, right? It's there 3 times. The goal is super simple, but the how? That's where things get interesting.
Okay, let's start with what might be your very first instinct. This is how a lot of us, especially when we're starting out, would try to solve this. It makes sense, and hey, it even works, but it has a hidden and pretty significant cost.
So the idea is pretty straightforward. You'd loop through each number in the list one by one, and for every single number, let's say that first one, you'd then have to scan through the entire list all over again just to count how many times it shows up. Then you do it for the next one, and the next one, and then the 2. You see the problem? We are just scanning and rescanning the same data over and over again.
And look, this approach will eventually get you the right answer, but there's a huge but coming.
And all that rescanning? Well, that leads to a technical term you might have heard, O of n squared time complexity. Don't let the notation scare you. All it means is that if n is the number of items in your list, the n squared part tells you the work grows exponentially. So if you double the size of your list, you don't just double the work, you quadruple it. For a small list, who cares? But for a really big list, this method just completely falls apart. It grinds to a halt.
So yeah, we clearly need a smarter way to do this. And this brings us to a much more elegant and way more efficient solution, the frequency map.
Okay, so here's the big idea. We're going to scan the list, but we're only going to do it once. And as we see each number, we're going to use a dictionary, you might know it as a hash map, to basically keep a running tally. And this line right here, this is the magic trick. It's so elegant. It just says, hey, for the number we're looking at, go get its current count. If we haven't seen it before, just pretend the count is 0, then add 1. That's it. It's a super clean one-and-done solution.
And the result? Our time complexity plummets from O of n squared all the way down to O of n. This means the work grows linearly, not exponentially. If the list doubles in size, the work just doubles. For any kind of large data set, the difference in speed is like night and day. It is a massive, massive improvement.
So how do you make this pattern feel, intuitive, easy? Forget the code for a moment and just picture a scoreboard.
The mental model is really simple. Step 1, you set up a blank scoreboard. That's our dictionary. Step 2, you go through the list. And every time you see a number, you just give it a point. You just increment its score on the board. And here's the really crucial part. Step 3, as you're updating the scores, you're also keeping an eye on who's in the lead. Who has the highest score right now? By the time you get to the end of the list, whoever's at the top of the scoreboard, well, that's your answer.
So let's just put it all side by side to really drive it home. The brute force method scans over and over and over. The frequency map, on the other hand, scans just once and stores the counts in its memory, its scoreboard. This one simple change in strategy takes us from a very, very slow algorithm to a very, very fast one.
Okay, so you might be thinking, why are we focusing so much on this one little puzzle? Well, it's because this pattern is so much more than a one-trick pony. It's a fundamental tool you can add to your programming toolkit.
Once you really get this count and track idea in your head, you'll start seeing it everywhere. Seriously, trying to find the most frequent word in a big paragraph, it's the exact same pattern. Need to find out if there are any duplicate items in a huge data set? A frequency map nails it, instantly. It's like a key that unlocks solutions to so many other common problems.
So if you only remember one thing from all of this, let it be this. The frequency map pattern is really just 2 simple steps mashed together. You count the frequencies of things and you track the maximum as you go. Count and track max. That is the whole shebang right there. So at the end of the day, what this pattern really represents is a huge shift in your thinking. It's about going from finding just any answer that works to finding an answer that's actually efficient and elegant. So I'm going to leave you with a question to chew on. Now that you have this scoreboard in your toolkit, What other kinds of problems do you think you could solve with it?